to the warm-up. Your warm-up, whoops, wrong one. Think. Final answers, 13/12. Second answer is 1/10. Keep in mind you're only allowed to add or subtract fractions if they have a common denominator, so make sure your blank is filled in as well. Okay, so I usually get a question at this point in time like, Mrs. Lucas, 13/12. Can I write that as 1 1/12? And you can, but please keep in mind the role of fractions in this section. The role of fractions in this section is to actually show you radicals in disguise, you know, using our ER rule. So if you write 13/12 as 1 1/12, well, how do you know what your root and your exponent should be? So my advice, my word of caution, if you will, is to just leave your answer as an improper fraction, and then I'll show you how to simplify with that in a bit. Okay, any questions on the warm-up? So please understand that there's two prerequisite skills that you have to be pretty good with coming in the door today. The first one, adding and subtracting fractions. Multiplying and dividing is also super helpful. In addition, the second skill is the skill that you were just assessed on, the properties of exponents assignment from last night. If those skills are okay, pretty sharp for you, then today's lesson's not really all that bad. So let's discuss what we're doing today. Today, what we're going to go ahead and do is use our properties of rational exponents to simplify radicals. So with that, there we go. We're on example 3. And our directions say simplify, and furthermore they say leave all answers in simplified radical form. So as you look at part A, you're like, oh my goodness, it's a mess. The question I like to pose to my college algebra students to start off this example is, can I just multiply right now, standing here, this x to the 5th times this x to the 1st? Can I use my product property for radicals on this? What do you think? No, very good. Why can't I? Ed. Yeah, very good. People who are good at math pay attention to the details. Eddie's noticing that this is a square root and this guy here is a cube root. And we don't have a product property that allows us to multiply radicands together when they're underneath unlike radicals. The radicals have to be the same for you to use that property. So we cannot use the product property for radicals. And the reason for that is because 2 is not equal to 3. Square root is not the same as a cube root. What's up? Yeah, but that still doesn't condense it down to one simplified radical. We're going to make it one radical by the end. Yes. Yes, very good. So we have to think of something else. The product property isn't going to work. And John's right now doing a little bit of problem solving. He's saying, well, can't we just write this first radical? So his eyes went here. And he's saying right now, can't we just write that as x to the 5/2? Sure we can. That'll help us. And then the second radical, you could just write that as x to the 1/3. And then it's like a problem from last night. So we can use those properties of exponents to actually help us simplify radicals. Pretty neat. So, does anybody remember what I would do with those exponents? Good. Not multiply. When we have like bases multiplied together, you actually add the exponents. Very good. So we have 5/2 plus 1/3 for the exponents there. You do add the exponents together. And right now that's a little irritating because the denominators, once again, are not the same. I know that 2 and 3 have a common denominator of 6. The least common multiple of 2 and 3, the smallest number they both divide evenly into is 6. So to change 2 into 6, I'd have to multiply that by 3. What I do to the bottom of a fraction, I must also do to the top. So 5 over 2 is the same as 15 over 6. And then 1/3 of 6 is 2. Furthermore, I would just multiply the top and bottom of this fraction by 2. 3 times 2 gives me the 6 I need on the bottom, and then 1 times 2 gives me that 2/6, that 2 in the numerator there that I was referencing. Now that I have a common denominator, I can just add straight across. The numerators, I should say. So I'm going to do 15 plus 2. 15 plus 2 is 17 out of 6. So x to the 17/6 is one possible answer. But if I go back and look at the directions, it says write it as a simplified radical. So I have to use my ER rule again to convert this back into a radical. So E over R, the root in this case, is always the denominator of your fraction. So this is going to be the 6th root of x to the 17th. And then we ask ourselves, how many times does 6 go into 17? And that's twice. And then there would be 5 left over. So we have x squared times the 6th root of x to the 5th. One radical, completely simplified. Questions about that? So out of this, we get a 3-step approach. I know some of you like step by step by step, right? So step 1 in every problem, when we can't use that product property for radicals, you can't leave the problem looking like a radical. You have to use your ER rule to write the problem as fractional exponents. So that's what I did in my first step there. Then I used my understanding of properties of exponents to combine or condense the expression. And then I used my ER rule again to get it back into a radical. So that's what I did there. Cool with that? All right, so on to the next. Boop. Part B. We have negative 5x to the 5/3 times 3x to the negative 3/4 power. Step 1, I'd use my ER rule to write it with fractional exponents. But that's done. Step 1 is done for us. I already have fractional exponents to work with, so I'm good. Step 2, use my properties of exponents to simplify. Remember, multiplication can be done in any order that you want. So I'm actually going to take a moment to rearrange this problem a little bit. I'm going to multiply the negative 5 times the 3. This is the associative property of multiplication. So I'm going to take negative 5 and group that together with the 3. And then I'm going to group my x's together and do 5/3 or x to the 5/3 times x to the negative 3/4. And then negative 5 times 3, that's pretty simple. It's just negative 15. And then I have x to the 5/3 times x to the negative 3/4. From the previous example, you might recall we could just add those together. It's a little irritating because the denominators aren't the same, so I'm going to show a little bit of scratch work. Common denominator for 3 and 4 is 12. That's the smallest number they go into. They both go into. And then if I want to turn 3 into 12, I have to multiply it by 4. What I do to the bottom, I also have to do to the top. So 5 times 4 gives me 20. And then if I want to turn 4 into 12, I have to multiply it by 3. What you do to the bottom of a fraction, you must also do to the top. 3 times 3 gives you 9. And then I can do that addition. The denominator just comes along for the ride. And then 20 plus negative 9 is 11. It did say write the answer as a simplified radical. So this piece right in here, that guy, I have to write that as a radical. That's the only piece, why I circled that, that's the only piece that has the exponent attached to it. So the negative 15, actually stays put. And then if I want to write x to the 11/12 as a radical, that's the 12th root of x to the 11th power. And that's actually done. To be completely honest with you, not holding any secrets back or what have you, this answer right here is also an acceptable response. Just like over here, x to the 17/6 would be an acceptable response. You can have fractional exponents. I just have to go one more step in these problems because that's what the directions requested. One of the answers is a simplified radical. If it doesn't say, you actually have a choice. And for those of you who have calculus in your future, you're going to see that the fractional exponents are usually a lot easier to work with than the radicals. So that's a little foreshadowing for those of you heading down that road eventually. You could just leave it like that. It's a little easier to work with. Questions about that? No? Okay. The next two sort of mimic the two that we just did. Again, today's lesson exercises a three-step approach. The first step is to write the problem so that it has fractional exponents. Because we can't use the product property in the problems today, the roots are not the same. So today kind of teaches you can use exponents to get around that. So again, step one, you got to write the problem with a fractional exponent. Step two, you have to use your properties of exponents from yesterday's lesson to simplify or condense. And then in the last step, you use your ER rule again to write the answer as a radical. So kicking off step one, I know that the cube root of x to the 4th is the same as x to the 4/3. And I know that the 4th root of x squared is the same as x to the 2/4. And I don't like 2/4, so I'm going to simplify that to down to a half. And then I'm like, oh, look, like bases multiplied together. I'm allowed to add those exponents. The common denominator for 3 and 2 is 6. The first fraction, I'd have to multiply the top and bottom by 2. So 4/3 is actually the same as 8/6. And then I have to multiply the top and bottom of the second fraction by 3. 1/2 is the same as 3/6. 3 out of 6 is a half. And then when I add fractions, I add straight across the numerator and bring the denominator along for the ride. So I have x to the 11 over 6. According to the directions, one more step. I have to turn that into a radical. So this is going to be the same as the 6th root of x to the 11th power. And then 6 goes into 11 one time. And there are 5 x's left over. I don't have to worry about absolute values in my answer because we're just assuming all variables are positive. So that is that. What's up? So 12 over 10, you'd reduce that. Any way you slice it, whether you reduce at the beginning or you reduce at the end, you're going to get the same answer. It's personal preference. If you want to hang on to that 2/4 and just reduce at the end, you can. But it was just jumping off the page at me, so I was like, oh, while I'm staring at it, I'm just going to break it down. Yes? Sure? You good? All right, and then in part D, I really like this problem because there's 2 different ways you could start it. But step 1 is already done for us. I don't have to write this problem so that it has fractional exponents. That's done. You would. Do you need me to work it out your way? Okay. Okay. So I got to ask. Ooh. No, go ahead. Uh-huh. It's always the exponent over the root, ER. That is, Brooke, to give you a reference, that is that rule from yesterday. I lied 2 days ago. We did just properties of exponents yesterday. Yeah, the order is important there. Definitely changes the problem for sure. Any other questions? Okay, so 2 ways to start part D, but I just want to hear what you have to say. I want to do it how you would do it. Your initial impressions of the problem. Like, what would you maybe do first? You would distribute the exponent? Okay, cool. So you would do the problem like 2 to the 4/3, x to the 4/3, 2 to the negative 1/3, x to the negative 1/3, and then you rearrange. Perfect. Okay. That's the way my period 1 class saw it. Just a little, like, fun fact, purely for your visual entertainment, you do not have to write this part down. My last period class, notice that we had like bases multiply together. You just add the exponents right there, and then that's your exponent for 2x. So that was kind of neat. They saw that. It works the same either way, though. So let's do it your way. We could rearrange this. You know, you put your 2's together, right? And you put your x's together. And then what I notice is I have like bases multiplied together, so I'm allowed to add my exponents. 4/3, take away 1/3, will give me my new exponent for 2. And then for the x's, you're going to have 4/3 plus a negative 1/3 as well. I think what you get is 2 to the 3/3, which is 1, and x to the 3/3, which is 1. So this is just 2x. I like to show work. I know you're shocked. What? Oh, one of us. I know.
Like you could have just, like you said, it's like basis, so you
3 over 3, and then that's 1, so it's just 2x to the first, yeah. But it's how you see the problem. If you don't see it that way, well, then this is also acceptable. Oh, the really long way.
I did have the same second step.
Oh, yeah, that's rough. Okay, any questions about this? Because you have 1 left to wrap up today's lesson. You have 1 left to try on your own. Okay, so you have this independent practice conclusion question. Try it. Please get it right. I'll show you the answer here in just a second.